Physics is imagination in a straitjacket. John Moffat. Physics is a branch of science which is usually defined as the study of matter, energy, the relation between them. It was called natural philosophy until the late 19th century and is still known by this name at a few universities. Physics, in some senses, the oldest and the most basic pure science, and its discoveries find applications throughout the natural sciences. Since matter and energy are the basic constituents of the natural world, physics today may be divided loosely into classical physics and modern physics. Classical physics is physics based on principles developed before the rise of quantum theory, including the special theory of relativity. Classical physics was found to suffer from many limitations. Inside the atom, and among atoms in a molecule, the laws of classical physics broke down and they generally did not provide a correct description. The introduction of the quantum theory solved many of these problems. Modern physics refers to the developed form of physics after the introduction of the revolutionary quantum theory. Evolution of physics. The earliest history of physics is interrelated with that of the other sciences. A number of contributions were made during the period of Greek civilization. Democritus proposed an atomic theory of matter and extended it to other phenomena as well. The most important philosophy of the Greek period was produced by two men at Athens, Plato and his student Aristotle. Aristotle in particular had a critical influence on the development of science in general and physics in particular. The Greek approach to physics was largely geometrical and reached its peak during the time of Archimedes. With the passing of the great civilization and the Roman civilization that followed it, Greek learning passed into the hands of Muslim world that spread its influence from Mediterranean eastward into Asia, where it picked up contribution from the Chinese, paper-making, gunpowder, and the Hindus, the place value, decimal number system with a zero, and westward as far as Spain, where Islamic culture flourished in Cordoba, Toledo, and other cities. Not much specific advance was made in physics during this period, but the preservation and the study of Greek science by the Muslim world made possible the revival of learning in the West beginning in the 12th and 13th centuries. During the period of scientific revolution, the first areas of physics to receive close attention were mechanics and the study of planetary motions. Modern mechanics dates from the works of late 16th and early 17th century. The works of Galileo and Simon Stevin in mechanics. The great breakthrough in astronomy, that is the proposition of the heliocentric model of the solar system by Nicolaus Copernicus, which was later modified by Johannes Kepler, were important contributions seen during this period. The period also saw Isaac Newton's famous work Principia, Mathematical Principles of Natural Philosophy. This work, the most important document of the scientific revolution of the 16th and the 17th century, contained Newton's famous three laws of motion and showed how the principle of universal gravitation could be used to explain the behavior not only of falling bodies on the earth, but also planets and other celestial bodies in the heavens. Other branches of physics also received attention during this period. William Gilbert, court physician to Queen Elizabeth I, published an important work on magnetism, describing how the earth itself behaves like a giant magnet. Robert Boyle studied the behavior of gases enclosed in a chamber and formulated the gas law named after him as Boyle's law. He also contributed to physiology and to the founding of modern chemistry. Newton himself discovered the separation of white light into a spectrum of colors and published an important work on optics, in which he proposed the theory that the light is composed of tiny particles or corpuscles. This theory was called corpuscular theory. A revival theory of light, explaining its behavior in terms of waves, was presented in 1690 by Christian Huygens. Later periods marked advances in the fields of mechanics, electricity, magnetism, and thermodynamics. By the late 19th century, most of classical physics was complete. and optimistic physicists turn their attention to what they consider minor details in the complete elucidation of their subject. The quantum theory of Max Planck laid the foundation for and led to the development of modern physics. With the passing of time, newer and highly interesting branches appeared in physics. Let us now look at some of the major branches in physics. Branches of physics. Astronomy. The study of motion, the structure, and the physical and chemical properties of material objects and energy sources situated outside the boundaries of the Earth's atmosphere. Atomic physics. The study of the properties of matter at the atomic scale. The study of the structure of atoms and the forces that act between positive nuclei and the negative electrons in orbits around nuclei. Cosmology. A branch of astronomy focused on the study of the origin, structure, and the evolution in space and the time of the physical universe. Dynamics. A chapter of mechanics dealing with the behavior of material objects under the action of external forces. Electricity. The study of the behavior of electric charges and the fields they create in their surrounding space. Electrodynamics. The study of the relations between electrical, magnetic, and mechanical phenomena. The study of the interactions between electric currents and the magnetic fields created by other electric currents. Field theory. A classical or quantum mechanical theoretical study of fields based on the knowledge of the field equations or of the commutation rules satisfied by the field operators. Fluid mechanics. The study of the properties and the behavior of matter in fluid, gas, or liquid state. High energy physics, also known as particle physics. The study of the structure, properties, and interactions of elementary particles. Hydrostatics or hydrodynamics. The study of the mechanical behavior of fluids and of solid bodies immersed in fluids, which are in static equilibrium or in motion relative to them. Magnetism. The study of magnetic properties of matter and the fields created in the surrounding space. Mechanics. The study of the behavior of physical systems in terms of their position in space under the action of external forces, which may be equal or different from zero. Nuclear physics. The study of the properties of atomic nuclei. The study of the structure of atomic nuclei and the forces responsible for the stability or disintegration of atomic nuclei. Optics. The study of light and vision. The study of the phenomena associated with generation, transmission, and detection of electromagnetic radiation from the short wavelength edge of radio waves 1 mm to the long wavelength edge of X-ray 1 nm. The study of electromagnetic radiation of any wavelength. The study of waves associated with particles, that is electron optics, neutron optics, etc. Particle physics, also known as high energy physics. The study of the structure, properties, and interactions of elementary particles. Plasma physics. The study of the structure and the properties of material in plasma phase. Quantum electrodynamics. A quantum theory of electromagnetic radiation. A quantum theory of the interaction of radiation with electrically charged particles, in particular with atoms and their constituent electrons. Quantum mechanics. A theory of matter based on the idea that material particles may be described as waves, and waves may be described as particles. Solid-state physics. The study of the structure and the properties of materials in solid phase. Statics. A chapter of mechanics dealing with the equilibrium of external forces acting on material objects. Surface physics. The study of the structure of the solid surfaces. The study of physical and chemical process occurring at the interface between solid objects and the gas or liquid environments surrounding them. Thermodynamics. The study of mechanical properties of matter related to heat energy.